Hi everyone, welcome back to Java Full Stack Flow. Today's Spring Boot interview question is, what is @transactional in Spring Boot? First, let's understand the definition. @transactional is a Spring annotation used for declarative transaction management. Declarative transaction management means we don't need to manually write transaction begin, commit and rollback logic. We simply define the transactional boundary using the annotation, and Spring manages the transaction for us. It ensures that a group of related database operations executes within a single transaction. If all the required operations complete successfully, Spring commits the transaction, which means the changes are permanently saved to the database. If a rollback triggering exception occurs, Spring rolls back the transaction, which means the transactional changes are undone. Next, now why do we need transactions? The main reason is data consistency. In a real application, one business operation may involve multiple database operations. For example, placing an order may involve saving the order, updating inventory, and storing payment related information. We don't want only some of these operations to complete and leave our data in an inconsistent state. Transactions allow related database operations to be treated as one logical unit of work. So, when everything completes successfully, we commit the transaction. If a failure occurs that satisfies the rollback rules, we roll back the transaction. Next, now let's understand how commit and rollback work. Consider a transaction containing two database operations. Step 1 executes successfully. Step 2 also executes successfully. The method completes normally. So Spring commits the transaction and the changes are saved to the database. This is the success case. Now suppose step 1 succeeds but step 2 throws an exception that triggers rollback. We don't want to keep only the changes from the step 1. Therefore, Spring rollback the transaction and the transactional changes are undone. This is the basic idea behind commit and rollback. Next, now let's understand this using a real-time money transfer example. Suppose we want to transfer 1000 rupees from account A to account B. This business operation has two important database operations. The first operation is debit, 1000 rupees from account A. The second operation is credit, 1000 rupees to account B. Ideally, these two operations should be part of the same transaction because together they present one money transfer. Let's first look at the success case. 1000 rupees is successfully debited from account A. The 1000 rupees is successfully credited to account B. Both operations are successful, so commits the transaction and the money transfer is completed. Now let's understand failure case. Account A is successfully debited by 1000 rupees, but while crediting account B, an exception occurs. If we leave the first operation as it is, account A loses 1000 rupees, but account B doesn't receive it. That would leave our data in an inconsistent state. So if the exception satisfies the rollback rules, Spring rolls back the complete transaction. As a result, the debt made to account A as part of the transaction is also undone. This is the one of the easiest real-time examples to understand why transaction management is important. Next, now let's discuss the default rollback rules. This is a very important interview point. We should not simply say Spring rolls back for every exception. By default, Spring rolls back for unchecked exceptions such as runtime exception and also for error. For example, if a runtime exception is thrown from our transactional method and propagates through the boundary, Spring normally marks the transaction for our rollback. But what about a checked exceptions? Checked exceptions do not trigger rollback by default. Now, what if our requirement says that a checked exception should also roll back the transaction? In that case, we can explicitly configure rollback rule. We can write @transactional with rollbackFor equal to Exception.class. This tells Spring that the configured exception type should also cause the transaction to rollback. We also have rollbackFor class name, which allows rollback rules to be specified using exception class names. But for a normal interview explanation, remembering rollbackFor is usually sufficient. Next, now let's look at the important points as shown here. The first point is, if a rollback triggering exception occurs inside a transactional method and propagates through the transactional boundary, the transaction is rolled back. Notice that I am saying rollback triggering exception, not simply any exception, because the rollback rules matter. The second point is, if the method completes successfully and the transaction has not been marked for rollback, Spring commits the transaction. The third point is very important. Be careful when catching an exception inside a transactional method. Suppose an exception occurs but we catch inside the same method and don't throw it. From the transaction infrastructure's point of view, the method may appear to have completed normally. Because of that, the rollback we expected may not happen. Depending on our requirement, we can allow the exception to propagate, rethrow it after handling, or explicitly mark the transaction as rollback only. Next, where we can use @transactional. We can use it at the method level or at the class level. If we put it on a particular method, the transaction configuration applies to that method. If we put it at the class level, it can provide transaction configuration for the applicable methods of that class. Which one we use depends on our application. Next, now if the interviewer asks what is @transactional in Spring Boot, you can answer like this. @transactional is a Spring annotation used for declarative transaction management. It ensures that a group of database operations executes within a single transaction. If the transaction completes successfully, the changes are committed. If a rollback triggering exception occurs, Spring rolls back the transaction. By default, Spring rolls back for unchecked exceptions such as RuntimeException and also error. Checked exceptions do not trigger rollback by default, but we can configure them using rollbackFor or rollbackFor class name. The main purpose of transaction is to maintain data consistency and integrity by treating related database operations as one logical unit of work. One more important thing is, in this question we are discussing what @transactional does. In the next Spring Boot interview question, we will go one level deeper and understand how @transactional works internally using Spring AOP, proxies and transaction management. That's it. If you found this video is helpful, please subscribe my YouTube channel and follow me on Instagram for more Spring Boot interview questions. Thank you.